This is A Somaiah, working as assistant professor in the Department of Mechanical Engineering at the Institute of Aeronautical Engineering. Today, I'm going to discuss about fluid mechanics and machines. So, where I will discuss about introduction to the fluid mechanics. So, the course objectives are the fundamental knowledge of fluids, their properties and behavior under various conditions of closed conduit and external flow systems. The development of various static and dynamic fluid flow governing equations from the fundamental conservation laws of motion studied under basic physics and classical mechanics. So next, the application of boundary layer theory, Euler's equation, continuity and impulse momentum equation in fluid flows. The another objective is the concepts of fluid mechanics and hydraulics to apply in real-world engineering applications such as hydraulic turbines and pumps in power stations. And the outcomes of this topic is the first one, relate the basic properties, various types and patterns of fluid flow configurations that are encountered in fluid flows. Next, identify the importance and applications of physical dimensions, units and dimensional homogeneity in engineering calculations with a specific emphasis to fluid mechanics. The third one is explain various effects of viscosity, static pressure and surface tension using Newton's law of viscosity, pressure difference and capillary rise. So these are the course outcomes which we need to come across. Otherwise, after the completion of this unit 1, we should be able to obtain these course outcomes. So, introduction. So, introduction to fluid mechanics is, so a matter exists in either solid state or the fluid state. So, the fluid state is further divided into the liquid and a gaseous states. So, basically, first of all, any matter, it may be existing in the state of solid, liquid or gaseous state. So here we are going to discuss about fluids only. The fluid means which may be capable of flowing. It may be liquid, it may be gas. So we are going to deal about fluid mechanics. That means we are discussing about only fluids and gases. So especially we will deal about only the liquids which are utilized for generation of power which are used and to study the concepts of boundary layer, and we are going to study the behavior of fluid at rest as well as in motion. So in fact, the same matter may exist in any one of the three states, solid, liquid and gaseous. For example, water which ordinarily occurs in a liquid state may also occur under natural conditions in a solid state as ice and in a gaseous state as vapor. So if you see the division of this mechanics, so where we can understand how the fluid mechanics is divided. So first of all, the mechanics is divided into two parts. So that is solid mechanics and fluid mechanics. So furtherly, the solid mechanics is divided into rigid body mechanics and mechanics of deformable bodies. So if you see rigid body mechanics, that is again furtherly divided into statics and dynamics, where dynamics is furtherly divided into kinematics and kinetics. Here, the fluid mechanics, if you see the division of fluid mechanics is divided into fluid statics, fluid kinematics and fluid dynamics. So the fluid static means where we can study the behavior of fluid and fluid properties whenever the fluid is under rest. So whenever the fluid properties are observed, otherwise studied under the motion, then you can call it as fluid kinematics and fluid dynamics. But there is a difference between fluid kinematics and fluid dynamics. So if you consider the fluid kinematics, so it doesn't consider the forces, otherwise pressure forces which are used, which are causing its flow. So the fluid kinematics is a study of behavior of liquid under motion without considering the forces causing its motion. That is fluid kinematics. So whereas fluid dynamics means, so this is also studies the properties of liquid under motion, but it considers the forces which are causing its motion. That means pressure forces, some other forces. It considers that is a difference between fluid dynamics and fluid kinematics. Now, the definition, if you see the definition of fluid, fluid may be defined as a substance which is capable of flowing. So, next, fluid mechanics is that branch of science which deals with the behavior of the fluids, liquids or gases at rest as well as in motion. So, therefore, the fluid mechanics basically it is comprising of fluid statics as well as fluid dynamics and kinematics. So it may be in rest or it may be under motion also. It studies the properties under rest as well as in motion. So thus this branch of science deals with the static, kinematics and dynamic aspects of fluids. So the study of fluids at rest is called fluid statics. And the study of fluids in motion where pressure forces are not considered is called fluid kinematics. And if the pressure forces are also considered for the fluids in motion, that branch of science is called as fluid dynamics. So the difference between the fluid kinematics and fluid dynamics is the component of force. If you consider the component of force which is causing its motion, that is known as fluid dynamics. If you don't consider the force component and you are going to study the fluid properties under motion is known as fluid kinematics. Therefore, only the force component is discriminating these two. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.